Here we go. So welcome again, everybody. Fish and Fisheries Seminar Series, and I mentioned this is we're really excited. And
The arrows.
Actually, two friends and colleagues here tonight. Dr. Angelia Vanderlaan, who is a postdoctoral scientist in our lab, Large Pelagics Research Center, and she's also collaborating right now with our other speaker, Dr. Moira. I'll start with Angela. Angela is a research scientist. As I said, she did her BS at Dalhousie. She did her master's, and that was in marine biology and statistics. She did her master's. This is to motivate the kids, if there are any here. Master's in statistics at the University of Victoria, and she did her PhD in oceanography at Dalhousie University. And I don't have to point out that she's a Canadian, as is Mo.
It's an invasion.
Angela's worked on, and she's our lead on our direct assessment program for bluefin tuna. And I'm really happy to say that today we found out that we were awarded with Angela to put down a direct assessment grant from NOAA to continue working with our fishermen partners to develop direct assessment for tuna. And Angela also worked as a statistician looking at breast cancer as part of her work, and also very much her work for a PhD was on right whales. So multifaceted. And Dr. Mo Brown here. Mo, I'm going to also crib on my notes. Mo, as if you've been following right whale work, you probably know that Mo is very famous, credentialed. She's the senior scientist at the New England Aquarium's John Prescott lab, and she's also, this is where I have to remember your affiliations, Mo, the Canadian Whale Institute. And Mo has her BS from McGill. If you look at her CV, she's on Wikipedia. She's done a lot of things. She's taught phys ed. She did her PhD at the University of Guelph after her BS, as I probably mentioned, at McGill. And Mo has been working, she's done many things, but she's been an incredible scientist and conservationist working on challenges to right whales. And I have to point out that Mo, among her awards included the Gulf of Maine Visionary Award, the Conservation or Canadian Environmental Award, and also, probably even more than this, but there's an International Fund for Animal Welfare. She received a Lifetime Achievement Award. So I think we're thrilled to have both of these right whale experts in our midst. And they're going to split the talk tonight and hopefully come back at the end for answering your questions. And I thought it would be really fun to get the diversity of the work that they represent. And so Mo's going to kick it off. And if you can save your questions till the end, that would
just
be
push
awesome.
the arrow.
And
Yeah, this is fine.
thank you for your attention, and please turn off your cell phones. Thanks.
Thanks very much, Molly, and thank you for allowing mammals into your tuna world. You get one of these whales on the end of a line, you really know it. It's a heck of a bigger fight than with a tuna. But anyway, we're not going to talk about that. Minimizing vessel strikes to endangered right whales. Tongue-in-cheek, a crash course in conservation science and policy. My part in this was conservation science and policy, but Angela really brought the statistical science to this effort that I'm going to describe tonight. Angela started doing this when she was actually an undergrad, so she's been really working on right whales a long time as well, and we couldn't have done many of the policy measures that we'll talk about tonight without her work. I'm going to go in and just talk a little bit about right whale biology, just a quick overview, and then we'll get right into the work that we've done to mitigate vessel strikes in Canadian waters. So right whales around the world. There are right whales in the southern hemisphere. They're doing really well. The population is increasing at 7, 8, 9%. They were hunted as well as North Atlantic right whales, but they are certainly doing much, much better than in their recovery than the species in our ocean. There's also another species of right whales in the North Pacific, and really very little is known about these whales. I think there's about 30 individuals in a catalog of photographically identified individuals, but more and more sightings are starting to come about. And so, for example, off of Vancouver Island last summer, there was a sighting of a right whale. They hadn't seen one in those waters for 60 years. So North Pacific right whales are still a little bit of a mystery. North Atlantic right whales that we're going to talk about tonight range from Florida up along the coast, primarily to the Bay of Fundy and off Nova Scotia, but also occasionally up around Newfoundland, and some of them actually go right up into the waters between Greenland and Iceland, and the odd one will also go up to Norway. We focus most of our work right along the east coast of Canada and the US. Now, there really is no mystery to the demise of the North Atlantic right whale, and in fact, it has the dubious distinction of being named by the whalers as the right whale to kill, because it floated after death, it was pretty coastal in its distribution, and it yielded the most oil and the most baleen. And that baleen that I showed you in that little video that we played ahead of time, those are the long plates of baleen that hang down from the whale's upper jaw. Now, we have been able to dispel one early rumor. If you go to some of the older history books on right whales, those books will tell you that the Basques in Labrador took somewhere between 12 and 20,000 right whales between 1530 and 1610. But through the miracle of genetics, we went up there about 15 years ago and collected a lot of samples. A lot of the bones from that Basque whale fishery are still lying on the beaches up in Labrador. Fascinating place to go to if you ever have a chance to go. And we drilled into those bones and actually found out that those whales were all bowheads. We found one right whale bone amongst the 400 or so that we looked at. And what the genetics also told us is that maybe there weren't as many right whales as some scholars have previously thought. Maybe the population was only in maybe the 5,000 to 10,000 range instead of the 50,000 range, which means we're even closer towards recovery, if you look at it that way. So we'll just get rid of that. Whoops, I didn't want to do that. Oh, it's all on one now. Okay, so, sorry, that was supposed to disappear. But what we do know with good records is the colonial whaling that took place along the shores of the US, in Cape Cod Bay, Long Island, all down along the New Jersey shore, down as far as Port Royal in Georgia and into Florida. And that started in the early 1700s, late 1600s, and really by about 1750, this whale was almost commercially extinct, that early. There was a brief resurgence in the whaling around middle 1800s, and then whaling was made illegal around the world for all species of right whales in 1935. But the history books show that somewhere between 5,500 and 11,000 right whales were taken during that time, and the whalers did focus on mother-calf pairs. So that was certainly a big hit to the population. We're going to jump forward to 1980, and that's when our photo ID studies began in earnest. The we is huge. We have an annual meeting of everybody working on right whales down in New Bedford in November, and we have about 150 people to 200 people at those meetings. So the we is many scientists working for both NGOs, science institutions, so New England Aquarium, Woods Hole. I mean, there's just so many universities and NGOs working on this species now, really from Canada down into Florida. And the staple of our work is photo identification. We can ID all of these whales to individuals using this pattern on the top of their head. So this is the boat we use up in the Bay of Fundy. We've used the same boat since 1980, and 3 engines, same boat. And we can get up close to the right whales that are up there in the summertime feeding and photograph this pattern on the top of their head and any scars. And because right whales wear their face on top of their heads, we can also photograph them from airplanes like this mother-calf pair. And the airplanes we typically use are Cessna Skymaster 337s, if there's any pilots in the audience, or Twin Otters are also really nice. But that's how we collect our data on individual whales. And so you can see we've been busy photographers since 1980. Nearly 70,000 records of over 500,000 photographs. Thank goodness we went digital a few years ago. It's made all the difference in the world. We've photographed 657 right whales during all of these efforts throughout their range. And we estimate right now that there's a little over 500 alive. Getting over 500, I think, meant a lot to us. I'm not sure it meant much to right whales, but it sort of felt like we were starting to get a grasp on the population increasing a little bit, which it is doing at about 2% per year. So here you can see the different patterns on the right whale's heads. These are like aerial shots looking down on the top of a right whale. And we have names for all of the different bits and pieces of the callosity pattern. And each whale has like a mug sheet that also includes some of the scars. This one was hit by a small boat and also has some entanglement scars. So here's one face on. And my boss, who Molly used to work with, Scott Krause, once said if this was 6 inches long and crawled on the ground, you'd step on it because it's so scary looking. I mean, this is a funny looking animal, okay? Humpbacks are, you know, a big fan of whale watchers. Right whales are really entertaining to see out at sea, but it is a funny looking beast. So this whale is coming towards us. That's the lower jaw, which in that little video at the beginning you saw dropped right down as it's feeding. The blowholes are back here. The eyes are down under the water on either side. So think about an old Volkswagen Beetle with fenders. And just think about the front of those fenders dropping down and the top coming up. And that's how they feed. This area here is called the rostrum. The black that you see is actually the callosity material. So callosity, just like calluses on your hands when you've been out raking. And the white that you see is whale lice. And it is the most endangered whale lice in the world because it lives on one of the most endangered whales. Here's a close-up of the whale lice. 3 different species, believe it or not, on right whales. And they have little backward-facing barbs on their feet, if you will, and that's how they hang on. And they can hang on well onto the callosity, and a colleague of ours actually dissected their gut and found that, yes, it did have callosity material in it. So that's what the lice are feeding on. And when you're working on a right whale that you're doing a necropsy on, and the lice are looking for a new place to live, make sure you have long pants on. So this is just another couple of photographs. Again, an aerial shot. And you can see yourself that these 2 whales do have a different looking pattern. Of course, this pattern looks very white in an aerial photograph, but when you zoom in on it, you can start to see the callosity pattern. These whales both have their jaws dropped down, feeding. Here's another one coming towards you. And there's the lower lip, and there's callosity material and lice on that lower lip as well. And here's a whale called Delilah, which we'll hear more about later. She's upside down with her belly showing. Her head is on this end. That's her flipper. And here's a whale diving that has a scar from an entanglement. All right, so what have we learned with all of these photographs? Well, right whales migrate from the southeast U.S. up along the coast and up into Canadian waters, but not all of them. So there's 3 big mysteries of the North Atlantic right whale that really still remain. The mothers and calves are found down in Florida in the wintertime. Give birth. Most of the calves are born December, January into early February. Gestation's about a year. Where the rest of the right whales are at that time of the year is pretty much a big unknown, and has been for 35 years. There are a few right whales in Cape Cod Bay, and those numbers really increase this time of the year. But in the wintertime, most of the right whales are unaccounted for. By now, the right whales are starting to come into Cape Cod Bay, and last year, they had 324 individuals out of a catalog of 500 animals seen in Cape Cod Bay, which is phenomenal for one habitat area. In the springtime, the right whales leave Cape Cod Bay and move out to where the plankton are more abundant out here, east of Cape Cod. And then in July, the animals start making their way across the Gulf of Maine and go up into the Bay of Fundy and Rosaway Basin, these 2 areas here. Bay of Fundy is primarily a feeding area. We used to see a lot of mother-calf pairs there. And Rosaway Basin is more of an adult hangout, adult males, adult females, kind of like a singles bar. And we see a lot of social activity out there, and I'll show you a video of that shortly. So one of the mysteries, we don't know where many of them are in the wintertime. The second mystery, of all the calves born down here, only 2/3 of the mothers bring their calves to the Bay of Fundy. We don't know where the rest of them go. Somewhere between there and Iceland. We still haven't figured that out in 35 years. The third big unknown, which we have a little bit of an inkling of finally, is where they mate. So if most of the calves are born December, January, February, and gestation's about a year, that means conception must be going on the previous year, and we think that it might be in an area called Jordan Basin in the sort of central Gulf of Maine. If you were in Bar Harbor and you looked almost due south about 45 miles, that's where Jordan Basin's located. And so we have an inkling from some aerial surveys and some vessel work that's been done out there, that time of the year might well be the timing and location of the mating ground. But it's a really lousy time to try and work out there. You have about 8 hours of day length, so surveys have been really challenging. Right whales eat plankton, copepods. If you're a right whale, this is the best filet mignon on the restaurant menu. Here's what it looks like when it comes right up out of a net, a sampling net. And I think I had a friend of mine work out that if you a daily menu of copepods for a right whale is equivalent to just under 2,000 hamburgers a day. That's a lot of food. This is a close-up of a single copepod, and this is all fat. Where you see this here, this is blue. This is all lipid. So this is like a giant stick of butter for a right whale. And here again is Delilah. She's skim feeding. This is a photograph of her actually from many years ago, probably the early 1990s, skim feeding in Cape Cod Bay, and mother of Calvin. So just remember those two names. Right whale calving, I mentioned they're pregnant for about a year, female lactates for about a year, then she rests for a year. And so they can really only have a single calf every 3 years at minimum. We have a couple that have had a calf on just a 2-year interval, but that's usually the case where the female lost the calf from the previous attempt. Now, the average calving interval is about every 3.7 years, but this is really an understatement of the reproductive problem of North Atlantic right whales. In order to get a calving interval, a female has to have 2 calves. And we have a lot of females that only ever have a single calf and never get, I don't know if they never get pregnant again, but they never produce another calf. And so this population does have a lower than expected reproductive rate. The average age for first calving is age 9. We had a couple of teenage pregnancies, and we also had a couple that didn't show up with their first calf until they were in their 20s. And those are some of the individuals that only have a single calf. And this here is a shot from Florida. You can tell by that nice green water of a mother and a fairly newborn calf. When the calves are born, they're about a little less than a ton, and about, geez, I gave this talk in Canada last time, 4.5 meters, 12 feet, about 12 feet long. So it's a big baby. This is the only graph that I have. Angela has way more. But it's really interesting because if you look from 1990 to 2014, you can see there's an awful lot of variation in the number of calves being born per year. 2000, we were pretty much all ready to give up and go find other jobs. Only a single calf was born. And then the very next year, there's 31. And what's really interesting about this is that, I don't have the earlier data on here, but from 1980 to 2000, on average about 11 calves were born per year. And then all of a sudden, we had this big crop in 2001, and then on average, right through to 2014, now we're averaging about 22 calves per year. So something happened within that right whale population to kind of get them over a threshold. More, a number of females surviving to the age when they can have calves, maybe better food during those times. We're not quite sure what it is, but we were very happy to see it. All right, ship strikes. Ship strikes are a big problem for right whales, and it is an accidental overlap. We've talked about them eating plankton and being coastal in their distribution. Here's the map from Florida up to Nova Scotia and Newfoundland, and you can see these little black tails along the map. And these are ship strikes, known carcasses of right whales where we were able to attribute the cause of death to a ship strike. We also have some open tails, white tails, and those are cases where we did find a carcass, but we were not able to establish the cause of death. Now, these warm colors, and the warmer they get, the more ship traffic there is. These are just numbers of vessel calls. But this is just an accidental overlap between right whale habitat and ships trying to get out to deep water when they get away from shore. So, what a huge problem to deal with. When you look at the distance from Nova Scotia down to Florida, how in the heck do you mitigate a problem that is so widespread? And when you think, we think about whales, they're huge, but compared to a ship, they're very, very tiny. So since 1970, we've had 28 vessel strikes, and this is actually through 2009 for a reason. And most of those vessel strikes actually occurred since 1991. So that might be because we're paying more attention and we're putting more resources into dealing with the carcasses, but nonetheless, it seemed to be becoming an increasing problem. And 6 of those occurred in Canadian waters, and that doesn't seem very many. But when we first started working on this, our population estimate was down around 300 right whales, and even at 500, every individual is critical. And this is the kind of thing that we are faced with when we get a dead right whale. And there's 2 slides coming up that if you don't want to look at anything kind of yucky, you may want to close your eyes. But this was a whale known to us as Stumpy. She was a known mother. And this is down off in North Carolina. And this fellow here who's got his back to us, Michael Moore, I think has not just right whales, but he's done something like 38 necropsies on large whales in his life, and he doesn't want to do any more. So we wanted to help him by dealing with the ship so he wouldn't have to do any more. And you can see the kind of equipment that's involved in just getting a whale ashore. So when we get the call for a dead whale, once it comes to shore, the next call is to a heavy equipment operator, because they are our best friends when we're trying to do this. So our goal has been for a number of years, when we get a call of a carcass like this, the goal is to get a team together to perform a necropsy to figure out the cause of death. So 2 not so great photos coming up. We have divided this into 2 categories of blunt trauma and sharp trauma. This is an example of blunt trauma where we find a big bruise on the animal. And in the case of Delilah, the whale I showed you earlier, she's unfortunately hanging in the New Brunswick Museum now. When we did a necropsy on her, we found a bruise that was 18 feet long. Just huge, deep under the, so what you have here is skin and blubber, and then now this is down into the muscle. But this is really valuable for figuring out what was the cause of death. And in some cases as well, we get shattered skulls, shattered jaw bones. Some whales have had upwards of 17 vertebrae broken in their backs from these kinds of traumas. And there's nothing else out there that could do that other than a large vessel. So all of those cases that I mentioned to you, we actually only know the actual vessel that hit the whale in 4 out of those 28 cases. But we've been able to build a case by virtue of all of this necropsy data. So up in Canada, the first call to action came in 1992, and that's 22 years ago. So this was a long-term project. We got a call that we had a carcass floating around the Bay of Fundy. In fact, the whale, a boater actually saw the whale die. It was thrashing at the surface. The boater went over, and the whale all of a sudden just went still and lay at the surface. And it had a calf with it. And the calf was subsequently named Calving. So what we did in 1992 is we thought, okay, well, a mariner awareness program. If the ships know that there's whales in the area, maybe that'll work. So in the Bay of Fundy, there are existing shipping lanes, and we went up and visited the operators in their offices up in St. John, New Brunswick, and we told them about the whales, and they said, okay, well, we can put out a whale alert. You tell us when the whales are there from your surveys, and we'll let the mariners know. So that seemed like a good idea. And we also worked with the Department of Fisheries and Oceans in Canada to come up with some conservation areas. Now, this has no legislative meaning at all in Canada, but what we needed something to put on a pamphlet, to put on a map, to show people where the whales were and where we wanted them to avoid. Now, just a slight side story. This was dreamed up by biologists and a fellow who worked for the Department of Fisheries and Oceans. And so we drew these up based on 95% of the sightings of right whales from 1980 to 1992, because this was early days. Drew a box around it. It wasn't very fancy. We just drew a box around it. And so he took that back to his bosses in Canada, and they said, no way we're making any conservation areas for right whales, We're all about managing the fisheries. We don't want to hear about right whales. But so he waited until his boss went on vacation, and he slipped them into the sailing directions, which is like the coastal pilot in the States. And he happens to be sitting in this room. But anyway, he hates me telling that story. But it's sort of along the lines of it's better to beg for forgiveness than ask permission. Those conservation areas were so key in all of the work that we've done since then. You really need to have a spot on a map to show people. We published them in a pamphlet, and we did a lot of mariner awareness with shipping industry, as well as the Canadian government. We also, another first, we were able to get all of this information written on the backs of the nautical charts that were being produced by the Canadian Hydrographic Service. So we really did a huge effort, and we had 2 more dead right whales, one in 95 and one in 1997, attributed to ship strikes in the Bay of Fundy. So we knew we needed to do more. And right around that time as well, in 1997, the first ship strike meeting was held at the New England Aquarium that brought many, many representatives from the industry together, along with government regulators, and that was really the launch point for ship strike measures in the U.S. Didn't help us in Canada. So the International Maritime Organization. I never thought I would learn about this, but it turns out that if you're dealing with routing and vessel measures greater than 12 miles from shore, it's the equivalent of international waters. Even though it's within our exclusive economic zones of our country, you have to go to the International Maritime Organization to make any changes or to even implement new measures. The IMO is part of the United Nations, and this is a typical group. It was really easy to go there as a female, because you can see there aren't any females in that room. So everyone gets to know you really quickly. It's kind of cool. There's representatives from something like 169 countries from all over the world, and they typically deal with things like collision regulations, safety of life at sea. So a marine mammal was certainly a new concept to them, and they weren't used to dealing with this. In 2001, we decided to really go full bore on this. We'd started to develop some contacts with the shipping industry, in particular a couple of companies that operate out of St. John, New Brunswick. And we literally just picked up the phone books, called everybody we could find in the marine industry, got instructions on who else we could call. We got 100 people together in a room, and we said, all right, we're going to tell you about the right whales and their problem. And then we're going to ask you, from the shipping industry point of view, what can you do? From that, we formed a vessel whale working group and ended up working with Transport Canada to come up with a new set of shipping lanes. So the old lanes, the pink is the median and on the edges, and then you have the new shipping lanes over here. Angela's going to go into all of the details about that. But we actually just shifted the shipping lanes over here away from the high concentration of right whales. Then we had to convince the Canadian government to write the proposal to the International Maritime Organization, because they won't take proposals from individuals. But we did that, the Subcommittee on Safety of Navigation. The lanes were amended. And our selling point really was to say that right whales were a navigational hazard. And they agreed. The shipping industry doesn't want to hit anything. They don't want to hit anything when they're out there. So there's the new lanes there, actually, as shown on a nautical chart. This is the new inbound lane, and what's noticeable is that the new outbound lane overlaps with the old lanes. And so what also made this possible to implement fairly easily is those fundy traffic operators I mentioned earlier. All of the ships going up and down through this area are on radar, and so they were able to guide the ships through the change in a very safe manner. We want to protect right whales, but we didn't want to risk any vessel problems, groundings, or anything like that while we were doing this, or any collisions. So that was all guided through a radar operation where each vessel is in radio contact at different points and monitored on radar. The industry partnership with shipping was really critical, but so was fishing, because previously you can actually fish in the shipping lanes in Canada, and that's not necessarily the same all around the world. So in this case, especially fishermen from Nova Scotia were now going to be fishing in these new lanes that were closer to their shoreline. And many of them run whale watch businesses in the summertime, so they have great appreciation for the whales. But we involved them right from the word go, because we didn't want this to be a surprise to them when it came about. We did get international support from the US, and this really was a first for IMO to put in a measure to protect an endangered species. And this was completed in the absence of any domestic legislation in Canada requiring Canada to do so. So by 2003, we had our conservation areas, we had our new shipping lanes, we continued with the Mariner Awareness Program, but then we had 2 more right whale mortalities. Not in the Bay of Fundy this time, but from this second right whale habitat called Rosaway Basin. We got the vessel whale working group back together again. There were no shipping lanes in this area, and the industry didn't want to concentrate the traffic by putting shipping lanes in. So instead, after considering speed reductions and recommended routes, we came up with an area to be avoided. And here's why. What do I have to do here, Ange? Just push?
You should just click on that. Come on, it worked this afternoon.
So this is a right whale mating group. And these are typically comprised of anywhere from 2 to, I think our biggest ever recorded was 58 whales. Usually a single female and all the rest males. Female lies upside down at the surface. And she's making vocalizations underwater and calls the whales in from all around. And then when she rolls over to breathe, there we go. Breath.
Oh, sorry, it's on the wrong screen. I can see it.
Going to the right.
So this is a typical kind of thing that happens out on Rosaway Basin, and these are some of our team members photographing the whales when they come up to breathe. There's the female right there.
So it's got a lot of.
And this is sort of a medium-sized group. I think there was about 20 whales in it. The whales are completely oblivious to anything when this is going on. So any ships sailing through here, it could have been disastrous. So this was a video that we showed to the shipping industry when we were consulting with them, and it was clear to them that they really just wanted to avoid the area completely. It's quite a party. Sometimes these events go on for 3 and 4 and 5 hours. The interesting thing is that this is outside of what we think of the period of conception is for right whales. So this is some sort of social activity that's going to be really important to them if they spend this much energy engaging in it, but it's outside of the period of time when we expect them to get pregnant. So that's sort of another mystery of the right whale.
Take you to the next slide.
Sweet. So back to the International Maritime Organization, and we redrafted the shape of that original conservation area so that it sort of paralleled the way the vessel traffic goes through the area. By now, we're actually consulting with 2 different committees within the International Maritime Organization, both the Marine Environment Protection Committee and the same subcommittee on safety of navigation. In 2007, we got an area to be avoided. Now, this area to be avoided is 981 square nautical miles. And that is because at the time, IMO had sort of this unwritten rule that anything under 1,000 square nautical miles was good, anything over was bad. So we got this through at 981, and I actually had a delegate from England say, well, you know, if it had been much bigger than that, we wouldn't have been able to support it. However, following the adoption of this a few years later, the U.S. was able to get an area to be avoided for right whales east of Cape Cod, and it's 2,500 square nautical miles. So we set the precedent, and they were able to follow up. And so this area to be avoided went into effect in May 2008. It is voluntary, but it's called recommendatory because it's been vetted by the IMO, so that's well respected within the shipping industry, and they also get circulars to navigation with it written right on. So the publicizing of this new area to be avoided was made easier by having it distributed through the International Maritime Organization. So all vessels greater than 300 gross tons solely in transit. That's a new slide, Ange.
I changed it. I do that.
So that's the policy side and some of the biology, and Angela is going to tell you
About the science.
about the science.
Sorry. So what we were interested in from the science side of things is to quantify the risk from overflowing vessels to right whales. But there's a lot of different definitions of risk when you look at the literature and between disciplines and even within the right whale community. And so we're estimating risk using the set of triplets idea proposed by Kaplan and Garrett. And what this is basically just 3 questions. And the first question is, what can happen or what can go wrong? And that's referred to as the scenario or the event, or an event. The second question is how likely it is to happen. So what's the probability that this scenario is going to occur? And the third question is, if it does happen, what are the consequences? So for our first question, what can go wrong? Well, a vessel can strike a right whale. And when you look at vessel strikes through time, there is a generally increasing trend, not only for right whales, but for all large whale species. Most frequently reported as victims are fin whales, humpback whales, gray whales, and right whales. But when you break it down on a per capita basis, right whales are 2 orders of magnitude more prevalent as. Now, when you look at all the necropsies whales in the Western Atlantic, for all large whale species, the number 1 primary cause of death is entanglement. But for right whales, when you just look at those, it is vessel strikes. So this is our question, what can happen, but how likely it is to happen. And to do this, we estimate spatiotemporal encounter probabilities. So what's the probability that a vessel will encounter a whale? And this is dependent upon two other probabilities. It's the probability of observing a vessel at some point in space and time, and the probability of observing a whale at that same point in space and time. Now if we look at a nomograph of our, can I have a pointer?
Yeah,
sorry.
sure. There's the button.
Of our theoretical model with the probability of observing a vessel along the x-axis, probability of observing a whale along the y, and our probability of encounters in the colored contours. When we have a high probability of observing a whale and a high probability of observing a vessel, you have a high probability of encounter. However, when you have a high probability of observing a whale and a low probability of vessel encounter, you get a nice blue color, so we have a low encounter probability. Our second, our third question is, what is the consequence? And we can estimate this based on historical records. Now, a lot of time in risk analysis, consequence is measured in a monetary value. So if, say your house floods, how much is it going to cost you? And that's what insurance would look in a risk assessment. But we can predict, or we can estimate the probability of a lethal injury based on a function speed at the time of the collision. And one of the reasons this works is because the vessels are much, much larger than the whales. And you can think of this as the bug on the windshield problem. If you're driving down the boulevard during the greasy pole competition and you hit a bug, it's likely that bug will survive a collision. But if you're leaving town and driving down the 128 and you hit the same bug, you're probably going to kill it and it'll end up on your windshield. So if we look at our model of this, where we have vessel speed along the x-axis and the probability of a lethal injury along the y, you can see we have very wide confidence intervals at low speeds, below 10 knots, and this is because there are very few records of vessels striking whales at this speed where we know the consequence, where we know what happened to the whale and we knew the speed of the vessel at the time. As the speed approaches as the speed goes above 15 knots, the probability of a lethal injury asymptotes to 1, and it's only at 11.8 knots that you have a 50% chance of killing a whale. So when you put all this information together, we argue that there's two ways to reduce the risk of a lethal vessel strike. Again, going back to a nomograph of our theoretical model with probability of encounter along the x-axis and our consequence. We're using speed to predict lethality along the y, and our risk of a lethal collision in the colored contours. We can either reroute the vessels around the whales, thereby reducing the probability of a vessel encountering it, or we can slow those vessels down where we will reduce the lethality should a strike occur. And when we first went in to IMO for the Bay of Fundy, we actually only ever had the encounter probabilities, so how likely the vessels in the Bay of Fundy were going to encounter a whale. And since then, we've been able to go back and do a formal risk assessment. And I'm going to be showing you quite a few figures like this, so I want to point out a couple things. The pink dashed lines are our study areas. These are the old traffic separation scheme, the right whale conservation area, and the colored contours are usually a probability estimate. Don't worry about the numbers, they tend to be very small, but the color scale usually represents 1 to 2 orders of magnitude. So before the amendment to the TSS, the highest risk occurred in that outbound lane where the lane intersected the right whale conservation area, and this is due to the aggregation of whales that you find in the conservation area, the number of vessels that transit through the shipping lanes within the Bay of Fundy. And the vessels in this outbound lane are transiting about 14 knots, which is slightly higher than the inbound lane at 12 knots, and at 14 knots you have a 70% chance of killing a whale if you hit one there. So after the amendment, and these two figures before and after are comparable, so they're on the same scales, you have a 90% reduction in that outbound lane where the TSS intersect the right whale conservation area. And we've also, in our risk assessment, gone back and looked at which option gives us the least residual risk, so which gives us a better protection for right whales. And these are the new shipping lanes within the Bay of Fundy. And if we look over the entire study area, by shifting those shipping lanes by 3 nautical miles to the southeast, we have a 62% reduction in the overall risk in the area. And the transit time for those vessels transiting the outbound lane is only increased by 1.4%. So we have very minimal impact on the vessels that are using this area. If we considered a speed restriction instead and applied a 10-knot speed restriction over the entire area, you would still have a great reduction in risk at 52%. However, the transit time for those vessels in that outbound lane increases by 20%. So we've had a really good reduction in overall risk in the area, and we've had minimal impact on the vessels that are using this area. Now, going to Roseway Basin, where things are slightly different, we've done the same types of analyses. Here in Roseway Basin, again, pink dashed lines are study area and the conservation area. This is the probability of observing a right whale. If you want to see one on Roseway Basin, go right here. Just don't go with me, because every time I go out, there's hurricane. It's because I go with Taggart. And within the conservation area, you're 26 times more likely on average to observe a right whale than outside it. And if we look at the vessel traffic, again, there's no defined lanes in Roseway Basin. And we see that most of the vessels are transiting to the north of that conservation area, and they're twice as likely to be up in this area. However, we have this diagonal emergent lane right directly through the conservation area. And that becomes even more prominent when we look at vessel speed. Vessels in this area, based on this first initial set of data, are transiting at about 7 to 15 knots. But right through the conservation area, they're going at higher speeds at 13 to 15 knots. Again, at 14 knots, you have a 70% chance of killing a whale. So the risk in this area is the highest within the conservation area. It's 68 times higher on average inside the conservation than outside. Again, and it's due to that aggregation of whales, the diagonal lane through the conservation, and the vessels transiting at a higher speed. So the area to be avoided was designed to encompass the majority of the risk, or the area of highest risk, and the majority of the right whale sightings. But we had this question, now that we've had this implemented, and it's a voluntary conservation measure, how effective will it be? The right whale conservation area was established. Mariners knew about it. They were asked to avoid the area if they could. If they couldn't, they were asked to slow down. This obviously wasn't the case of what was happening on Roseway Basin. So we initiated VACATE, which is the Vessel Avoidance and Conservation Transit Experiment. And to do this, we're using AIS data, which is an automatic identification system data. And basically what AIS is this ship broadcasting over radio frequencies that this is who I am, this is where I'm going, this is how fast I'm going. It gives us information on both static, dynamic, and voyage-related data. We have a location for each of the vessels in the area and its speed every minute. And we have a full year of data prior to the implementation of the ATBA. And we were working with Bell Alliant, and they allowed us to put our receivers on their cell phone towers. So to measure compliance, within the first year, it was initially estimated semi-monthly. I'm now estimating it on a weekly basis. I looked at both the pre-ATBA and the post-ATBA data to determine compliance for individual vessels. So I look at every vessel track that goes through this area. This is my vessel domain in the green box, and then the magenta is the area to be avoided. This vessel used to transit through the area to be avoided, and after implementation, it is now going around. This vessel has not changed its pattern since the implementation of the ATBA, so it's clearly not avoiding. And when it gets to my study domain, I just don't know what this vessel is doing. The track is incomplete. We've lost the signal for some reason, probably due to weather, and it goes into an uncertainty estimate. So within the first 2 weeks of implementation, we had 57% compliance within the ATBA. Here's the time from the 1st of June to the end of October and the percent compliance. Within the area to be avoided in 2008, and it generally ranged from 62 to 87%. The area to be avoided does go through December. I'm only showing you here to October. The data gets a little bit we get a lot more incomplete tracks after October due to signal loss. And when we look at the cumulative compliance within the first year of implementation, it's stabilizing at about 71%. So we redid the risk analysis, and this is the probability of observing a vessel pre-ATBA, and this is based on the AIS data. Again, you see that strong signal from the vessels that are transiting north of the area to be avoided, but you'll also see that the diagonal traffic lane through the conservation area. And this becomes even more prevalent when you look at the speed. The average speed for that lane that's going directly through the conservation area is 16.5 knots. This is slightly this is higher than what we were previously estimating, and that's based because the old data that we had used had been binned into 5-knot intervals. And at 16.5 knots, you have an 87% chance of killing a whale. When we look at the data after the implementation, again, this is based on the 2008 data, you still see that strong signal above the area to be avoided, but the diagonal lane has shifted to the southeast of the ATBA. And there are still vessels transiting it, the area to be avoided, but you can see a definitely shift in the traffic patterns in this area. When we look at vessel speed, again, you can see that lane that's still going through, but the vessels that are transiting now are going at a slower speed, and they're only going at 15.2 knots, so you only have approximately 80% chance of killing a whale, which is still pretty high, but there's a lot less vessels. So when we look at the risk, again, here's the risk estimated from this AIS data. It's encompassed within the area to be avoided, and this has been standardized, so pre and post are completely comparable. And you can see that it's been decreased significantly within this area. There's still risk there, but it's been decreased. And due to voluntary actions of the shipping industry, we've had an 82% reduction in risk within the first year of implementation. Now I just want to show you the vessel traffic again to really illustrate how much it's changed out here. This is all the individual points of the data that I get. There's each color represents a unique vessel. Again, you see that diagonal lane directly through the ATBA. So this is prior to implementation. This is the first year. You see the area to be avoided start to empty out. There's still vessels that do transit it. Again, they do so at a slower speed, and you see that new lane that's emerging to the southeast of the ATBA. And in 2009, it's emptied out even more. So we've had a significant change in the distribution of vessels within this area, and we've been able, through Vacate, we've been able to demonstrate that the shipping industry is willing to voluntarily alter their course to protect right whales. Now, this isn't the only thing that we've been able to do with Vacate. We're also part of a letter writing campaign, so we have direct communications with the shipping industries. We congratulate all those vessels that avoid the area to be avoided, and then we send another letter out to the non-avoiders and trying to increase the awareness so they hopefully change their routing measures through the area. We're hoping to achieve 100% compliance. I'm also and I'm going now back through the data and looking to see if they got a letter, did they change their next transit through the area. But I don't have any information on that yet. And we have gotten some responses from company. They've requested more placards for distribution to their crew, and they thanked us for efforts and vowed to increase awareness among their fleet. So in Atlantic Canada, we had two goals: reducing the potential for lethal vessel encounters with right whales, and we're trying to do this with minimal disruption to the vessels that are transiting this area and keep their safety in mind. You saw that shift in the Bay of Fundy and on Rosaway Basin is very small in terms of increase in transit time, so this had little effect on them. And these two measures were implemented by Transport Canada, and we've done it without we've done it in the absence of legislation. And then in 2009, things are still happening for right whales in Canada. We have critical habitats defined under the Species at Risk Act. Now, Canada has done a lot to protect right whales, but there's been a lot that's also happened in the United States of America. For mariner outreach and awareness, there's an app for that. Whale Alert will let mariners know when there's whales present in the Boston shipping lanes. They also have a whale dolphin 911 for reporting stranded animals that are important for necropsies. There's been federal regulations implemented, including 10 knot speed restrictions in seasonal management areas. They also have dynamic management areas that ask vessels to voluntarily slow down to 10 knots. They also have voluntary recommended routing. United States of America has also gone to IMO and have mandatory ship reporting systems put into place, and that's helped them build recommend routing through the southern Calving ground. They've made, similar to the Bay of Fundy, they've made modifications to the Boston TSS, and they, as Mo said, they have the ATBA in the Great South Channel. I'm going to switch it back to her now.
Are you okay?
Yeah, just careful.
All right, so lessons learned. When I first showed you that call to action slide, that was in 1992. And that is 22 years ago, and it really has been a long campaign to do all of these things. But I think, as you can tell from listening to my talk and Angela's talk, we had really solid data for analysis, both whale data, individual ID data, as well as Angela's probability and risk analyses. We did something a little bit new in Canada in that we involved all of the marine users from the first meeting, and that was shipping, fishing. It also included whale watching industries and environmental groups. And by going through the International Maritime Organization, it meant that they really did our advertising for us. In other words, once these measures went into place, there's regular circulars that come out from IMO that go to the shipping industry that they then give to their captains and put on the ships. So I would say the one thing is that you can't give up. It did take a lot of persistence. Once the Bay of Fundy shipping lanes were moved in 2003, that was 11 years from when we first lost Delilah. And some of the folks I work with said, well, geez, it was a great idea that was probably hatched out over a couple of beers. We never thought it would work. And I went, really? I said, geez, I'm glad you never told me. Because I always thought it would work. It was just going to take some time. It took us another 5 years, really, to get to the area to be avoided, and then we've been monitoring ever since. And I think I'm really glad that we developed the monitoring scheme. The International Maritime Organization doesn't require any monitoring schemes at all, because many of the areas, many of the places in the ocean where they put areas to be avoided are far from land, and there really is no ability to monitor, although that's changing now with this automatic identification system. But reporting results back to the industry has really been interesting, sending these letters out and getting the phone calls and letters back. We've mostly just had great response from the shipping industry, and no angry calls yet. The only excuse we ever had one time was like, well, the weather was really, really bad, and so we decided we needed to stay closer to shore. So I went back and kind of looked at the weather from that day, and it wasn't that bad. But anyway, so will we be successful in the long term? Angela did a really quick review of what's gone on in the U.S., but right now, right whales enjoy more protection from the shipping industry, from ships at sea, from throughout their range, from Florida to the Bay of Fundy, than they've ever had. We put a lot of science into this from really a study now with right whales that's been going on since, 3.5 decades, since 1980. The undertakers, the guys who go out and do the necropsies. It is no simple thing to do a necropsy and take a right whale right down to bone. It is a job where often it takes a team of 20 people several days to do it on the beach. It's a huge undertaking, and they deserve a lot of credit. We had good collaborations right from the word go through some really key partners in the shipping industry especially. And I think we had amazing compliance that we've seen in the first few years. But we really need to keep on it. Ships change their routes. We get new ships coming into new areas. And part of the reason Angela is looking so closely at that right now is we actually need to know if we need to go back to the IMO and say, hey guys, don't forget about the Rosaway Basin area to be avoided. The shipping lanes aren't a problem because they're mandatory. But these areas to be avoided are recommendatory, voluntary. So we really need to see if we need to go back and re-communicate with the International Maritime Organization to put the word out there. We were also very honest with the shipping industry right from the word go. It was an experiment. We never knew if this was going to work. In fact, one of the questions I had early on was, well, if you move the shipping lanes, are the whales going to move too? And, it's like, gee, I never thought of that. But it was a really good question. But it turns out, these whales are really focused on feeding at that time of the year, and they're really aggregated in those areas because that's where the highest concentration of food has been found. So we felt pretty safe that if we moved the lanes into, shallower, not really that much shallower water, 500 feet deep instead of 700 feet deep, that the whales would probably stay put because they were anchored to their food resource, and that seems to have been the case. And the shipping industry was really, really key in getting them on board. Nobody who's out on the water wants to hit anything, and they were very honest about that as well. And this was never an activist effort. This was a solution-oriented effort where people who knew whales and people who knew ships got together to simply try and find a solution. And the stewardship part of it, I think, is really, really valuable. That's the letter writing part. Staying in touch with the shipping industry. I often get calls from ship captains I've been in touch with, and their first question to me is not, hi, how are you? It's, hi, how are the whales doing? So time will tell if we're going to be successful or not. But I think so far we are. There have been, since all of the measures went in place in both Canada and the U.S., in particular in the U.S., there was a ship speed rule that was put in place in 2009, and that slowed vessels down to 10 knots or less, 20 miles from shore, seasonally, right along the coast from Florida up to Boston. It wasn't blanket all year long, but it was seasonally in each of the areas as the animals migrate up. And since that speed rule was put in place, there's only been 2 right whale mortalities. None of them have occurred in the seasonal management areas. So they've occurred outside of those. So we didn't really make the seasonal management areas big enough. They were, we were probably we were too conservative on the size of those areas. But that's an incredible difference over 5 years. And again, it's just giving every right whale a chance. So I mentioned Calvin early on. So Calvin was this little calf who was forcibly weaned when she was only about 8 months old in the Bay of Fundy when we lost Delilah. And here's a picture of her actually in the Bay of Fundy. She showed up in the bay in August. Here's Calvin and her mom, and they showed up in August, and we got some pictures of them. And most right whale calves are with their moms for a year before they're weaned. So we never expected to find this whale again. We did go looking for it, and it's probably good for the whale that we never found it. I don't know what we would have done. There's no way you can feed it the milk that its mother would have, so it's just as well we didn't find it. The very next year, in 1993, we got some funding to do some early season surveys, and lo and behold, who shows up but this little whale? So I named it Calvin, right after Calvin and Hobbes, because I thought it was a pretty precocious little whale to survive losing its mom. Then we biopsy darted it, and we found out it was a girl. So, you got to stick with the name, right? But I think it makes me very happy that in 2005, Calvin brought her first calf to the Bay of Fundy. And it was a really very, very different Bay of Fundy than her mother had been faced with 13 years earlier. And we'll stop there. Any questions?
Is the genetic pool diverse enough for there to be for them to expand successfully on their own ultimately when this mechanical business is taken care of with the shipping?
We started taking skin biopsy samples from right whales in 1988, and actually I can say that I did my PhD on sexing right whales because at that time we couldn't tell them apart unless they rolled over, which they actually don't do all that often. So now we have skin biopsy samples from about 75% of the whales. There's some we'll never get because they died before the program started. And right whales do have some problems. They don't have the most genetic diversity in the world, but they're not too badly off. We are seeing some new matrilines, some new female family lines just through normal mutations. And the cool thing is that we actually know something about the whales they probably don't know about themselves. And that is we can determine paternity. And so we actually have been able to identify quite a large number of fathers within the population. So we have a skin sample from the mother and calf, and from that we can try and identify the father. And the other little interesting piece that came out of that is when we started doing that, we weren't finding as many fathers amongst our sampled population as we would expect. And I haven't done the genetics work for a long time, but a couple of graduate students worked on this, and we actually think there may be about 10% more right whales out there than we've been able to photograph, and sample. 10% more males, and so that probably means 10% more females as well. So in all likelihood, there are more right whales out there than we've been able to capture in our efforts, which are mostly pretty near shore. The animal does still range up to Iceland and Norway. On occasion, we get reports of those sightings. So I think it's encouraging. We're up over 500 individuals in our catalog. If there's 20% more out there, that's even better. So yeah, they're not going extinct because of inbreeding or anything like that. I mean, it is promising. It's not as good as we'd like it, but it's promising, and it perhaps will do better as the population increases.
Is the impacts of climate change, has it caused any change in their migrations or their food sources moving? Anything that you've been able to ascertain?
Well, right now they're driving us crazy because the right whales aren't behaving. We expect to see them in the Bay of Fundy in August and September. And last year, we had five individuals in an area where some years we've seen over 200. And so, yes, I would say the short answer to your question is yes. There's no predicting it. And so we're sort of stuck in this turmoil right now. If we really want to go back to our critical habitat areas and all the places where we've done all this kind of work to try and protect right whales to see if they're there. If they don't show up, then we need to become responsive to that and try and find them somewhere else. So we've actually, last summer, we went back to what we did 30 years ago, and we started calling up our friends in the fishing industry and saying, have you seen any right whales? Because we're not seeing them in the usual places in Canadian waters in the summertime. They finally did show up south of Nova Scotia towards the end of September. But I think this is probably just the tip of the iceberg. We may well be shifting operations and starting over with these kinds of protection measures in new areas for right whales as if they shift distribution.
You should put tracking devices on 500 10% population.
Got an idea on how to do it? Well,
Skin samples.
yeah, we have. There was quite an extensive satellite tagging program that went on first in 1988 and 89, and then again in the late 1990s. The problem was the tag was, 22 centimeters, so about that long, about that big in diameter, and it was designed to go through the skin, through that 12 inches of blubber, right down into the muscle. And we started to get really concerned about killing a right whale from tagging it. So it wasn't done through the aquarium. It was done actually by some colleagues from out west that came to the Bay of Fundy to do it. And we just decided it was too risky. If we're asking ships to slow down and change their behavior and asking fishermen to change their behavior on the water and change their gear, we certainly didn't want to risk killing a right whale from science. And so we're waiting for the technology to come along. The problem is the antennas. You saw that little clip on the surface active group. These animals are so physical with one another that the antennas just get destroyed. And so we need to come up with something different. I had this dream idea of attaching something to their callosity with a little paddle wheel to power it, or I don't know. No, it's all kind of Star Wars, but then so's a lot of the stuff we take for granted today. So,
Well, you can donate.